In general, there's a reason why we want to know whether data are left skewed or right skewed. This is part of the shapes that we're looking for on a histogram. So let's take a look for a second, see what right skewed data looks like. Here's what we're going to call some salary data that we're going to put on a histogram. And you'll see some other shapes, but salary data does tend to be right skewed. That is, most people make a typical amount, a few people make a very large amount. I'm going to take a look here at a histogram using a different feature in Minitab, Stat Basic Statistics Graphical Summary, because I want to see what happens to the mean and the median in this case. So we'll see the data are right skewed. This means around 50,000, and the median here around 35,000. So in right skewed data, the mean is going to be larger than the median. And if we look closely at the graph, we'll see that the mean's here a little bit higher up, the median a little bit closer to the tallest bars. That is, in skewed data, the mean is more representative of what's typical. Now, that doesn't mean that the median is all we care about. Let's take a minute here. I'm going to store some statistics. We're going to do this for the salary data that's right skewed that we're looking at. And we're going to put the mean there, we're going to put the median there, and I'm also going to add in the sum and the number of observations in the data set. We get used to n being the sample size. And if I go into Minitab now and store some multiplication, then we'll get a chance to look at the different properties of the mean and the median, besides that the median is more typical. So first, let's take a look at what happens when we multiply the mean by the sample size. We're using the asterisk here for multiplication, and lo and behold, this number, the mean times the sample size, is exactly the same as the sum. Now, if we take a look at the median times the sample size, you'll have some anticipation of what's coming because we know that the median is smaller than the mean when the data are right skewed. So when we go ahead and do this multiplication, we find that the median times the sample size is much smaller than the sum. That means that if what you'd like to do is look at how much money everybody's going to be paid in salary altogether, you can multiply the mean by the number of employees and get that number, the sum. You can't do that with the median, when their mean and the median are different. So when the data are skewed, the median is better at describing what's typical. The mean is better if what you ultimately need to do is estimate a sum or a total. Now, of course, you can also have less skewed data. That's where the bulk of the data is on the right and there's a tail pointing to the left. In this case, the mean is smaller than the median. So you'll see the opposite relationship in left skewed data than we did in right skewed data.